Amazing, we're live. Hello, good evening. I am so excited to be in Edinburgh. It is so beautiful. Every time I come here, which is the third time now, yeah, your castles are amazing. Beer is amazing. Whiskey is amazing. You would never want to leave. I might stay here. Yeah, so today we're going to talk about security and authentication in React Native. I put React Native because I am doing this in the context of React Native, but really it's security and authentication in mobile applications. So if you do plain iOS and Android, a lot of the stuff is still applicable to you. If you're the kind of person that likes following along with slides, this is a possibility. So if you go to slides.com/Kadi Kraman/rn-security, if you do /live, you can see the slides as I turn them. And if you do /full screen, you can just swipe backwards and forwards. But it might be spoilers, so I wouldn't do that. So that's me with straight hair. At the moment, I am a senior software engineer at Formidable, which is an awesome JavaScript consultancy. We're big on open source. We're big on, well, anything JavaScript, front-end, back-end, database side, mobile. We like JavaScript. And I've been doing React Native almost full-time for the past 2 years. So today, I'm a senior React Native developer, because it hasn't been along for that long. Oh, but I forgot to mention, I actually brought some stickers and some M&Ms for the people, like it's near the booze, so you might want to grab them because there's only like 6 packets, and they're amazing. They're by M&Ms, but they do have a little Formidable logo, so if you want some M&M swag, go for it. Cool, so mobile development. A long time ago, well, not that long, when I was a junior developer, at a scientific programming company, I was like, how do mobile apps work? I'm quite curious. So I went on Coursera, as you did at the time, and I did a course on building mobile applications for Android. And that was really hard. I didn't like Java. And I was like, I finished the course, I got a certification, it's on my LinkedIn, so you know it's legit. And I kind of never kind of thought about it again for quite a few years. I was never intending to be a mobile developer. But then, yeah, so React Native came along, and you could do it in JavaScript. So now I am a mobile developer. And you can be too, which is pretty cool. And today we're going to talk about security. It's going to be in 2 parts. So one part is like general advice on what not to do, which is applicable for everything, just where to store stuff about and security of information. And the other half is about authentication in particular. So the first half will be less technical, second half will be a little bit more technical. There might even be some code. Cool, so secrets. Well, these are kind of rules of thumb for web as well as mobile. But basically, if you have information that a user shouldn't see, then you should not send it via network request, you should not ship it in your app code, and you should not save it to async storage. And I'm going to go through all of these 3 points one by one. Right. I don't know if any of you remember this, but this was a couple months ago, well, almost half a year ago now. 3fun was, probably was, maybe still is. But it's a dating site. It's an alternative dating site, as the 3 might imply. And they were in the news for a really, really bad reason. Namely that they managed to quite badly leak their customers' data. And let's have a look at how that happened. Well, this is a screenshot of a proxy site where you can see information from network requests. And this is available if you plug your phone into your laptop and you use a proxy app. And you can see that in this response, you can see plain data for users, particularly their location, which is not something you want everyone to know, because this is a live location that's used to match you with other users. So that's pretty secure, pretty dangerous thing to share. And the other part is there's a key in JSON called private photos, which are filtered on the client side. So that's pretty awkward. You can only imagine what was there. I don't want to imagine. That's why I've created that. Yeah, so that's embarrassing. And you might be thinking, well, I mean, that's pretty obvious. Like, it wouldn't happen to me. I would never be that stupid. And yeah, I kind of thought that as well. But I've got to be completely honest and say that that has kind of happened to me. And for your entertainment, I will tell you what happened. So I was building this app, and the app had a page where you could see a list of all the users that are using. It was like a community app. You know, you log in, you can interact with the other people in the community, and there's a list of all the community members. And you can see them, you can see their interests and stuff. And as a user, you could set your profile to be one of three ways of visibility. So you could be public, protected, or private. So if you're private, you shouldn't show up at all. If you're protected, you should have the avatar and a name. And if you're public, you have the avatar, name, and then just all the general interests and bio. And this is kind of what it looks like, roughly. Imagine that, but on a mobile app. Right, and this was the API that was given to us. Now, I didn't build this API. This was the API that the API team built. I just had a requirement with this design and this API, and I built it. Now, you might have already noticed what I did wrong. And what I did wrong is that I didn't question the API response that I got, because you might have seen already that in this API request for a public user, I can see not only their first name, last name, and avatar, but also their phone and email, which I don't actually display and have no right to send. So what happened is there are a bunch of people out there who are security bounty hunters. So they, depending on how popular your app is, but they would literally go on your app and try to break it, try to find flaws. And as it happened, one of our beta users was one of these bounty hunters. He immediately, first thing he did on test flight, he hooked the app up with a proxy site, looked at the network request, emailed us saying like, hey, got a bit of a problem. And we were like, oh, we're so sorry. But yeah, so that was embarrassing. I hope you learned from my mistake and never think that you can't question the data that's given to you, even if you weren't the one that actually originally built it. But because of this, it actually made me think, all right, so how easy is it really to look at the network traffic on a mobile app? So that's the right slide. So yeah, I decided to try out. And feel free to try this at home. It's actually quite fun if you have lots of apps and you want to know, want to do a bit of snooping. So I used an old iPhone. You can use a new iPhone as well if you want, but I used an old one because we had to install some certificates. So I didn't want to mess with my actual phone. I used a MacBook Pro. I actually used this one. And I used a proxy app. Any proxy app will do. I used Charles Proxy. It's nice. It's got like a little jug as an avatar, which is quite funny. And just any Wi-Fi network. So your home Wi-Fi network will do. So it took me about half an hour to do this just by Googling. And if you want to do this, you can too. So I'm sure no one's actually going to try to sniff their network traffic using these slides. But just as a high-level overview of how you would do it, you download the proxy app. You configure your mobile traffic to go through the proxy app, which is basically you connect to your Wi-Fi. There's a setting on the Wi-Fi that says proxy. You configure it to go through Charles Proxy, which is a specific API endpoint with your LAN IP address. And then you need to install the Charles Proxy SSL certificates on your phone because almost all network traffic is via HTTPS, which means you wouldn't be able to see it plain text otherwise. And finally, you enable SSL proxying on all hosts via Charles Proxy, so you would be able to see all the network traffic. And you have to install some scary certificates. So this is fine, but perhaps not on your actual device. And you're in, yay! Which is actually quite fun. I really enjoyed this part. One caveat: if you ever heard of SSL pinning, It's a very clever thing that you can do on your mobile app, which means that your mobile app will only the how do I explain this? Most SSL traffic needs an SSL certificate, and then for a lot of traffic, you can go like, okay, don't worry about this. I'm going to create my self-signed SSL certificate, and this is fine. Just give me the data, it's fine. But if you have used SSL pinning, this means that you embed your SSL certificate within your app, which means that only that app can see the actual content of that SSL request. So any APIs, for example, Facebook or Twitter, wouldn't show up because they actually use SSL pinning. So all of these apps that I'm looking through here, they haven't used it. They could. It's not a huge security flaw if you don't. It makes it harder, but just a caveat why Facebook is not here. Cool, so here's Slack. That's cool. Got some Slack responses. Here's LinkedIn. It's also fun. They have some strange API naming conventions, but nothing too terrible. Yeah, I wasn't too sure about this one. Virgin Active. Does anyone here use Virgin Active? No? All right. Yeah, maybe it's just in London, but it's a gym. It's a really nice gym. It's a gym I go to, and I've got an app for it. It's just a small app. You log in, you can book yourself to classes, you can see if you lost any weight or gained weight, all that kind of stuff. Anyway, so yeah, it's a small app, so I can see all the network requests. You can see I've got this /member/detail. You can see that's me. I'm from London, all that kind of stuff. And then when I went in there, I noticed this. There's a call to auth. I was like, all right, what's going on here? Maybe what's going on in this method body? And it turns out this is the actual call that they use to get my refresh token from the state and exchange it to a JWT. So I was like, all right, if I copy all this to Postman, can I just call that API? And it turns out I can, which is pretty cool. And the thing is, this is not a security flaw. This is just a thing that users can do. And you can do it on the web as well, but for some reason, for mobile apps, we kind of have this feeling that they're very black boxy and people can't access stuff easily. And it's true, it's harder, but if you have 20 minutes of time and a MacBook and a phone, you can pretty easily. So from a lesson, anything that the user shouldn't be able to see in plain text, you shouldn't send via a web request and never filter things on client side. Cool. Right, time for the second step. Do not add sensitive info into your app code. Right, some of you might have seen this Jane, who is amazing, on Twitter. If you haven't, I would follow her. And because basically she's from Hong Kong and she calls herself, I think, a security researcher. And what she does for fun, this is not her job, she does this for fun, is she takes popular apps like Facebook, like Twitter, like Instagram, and as soon as there's a new App Store release, or rather Play Store because she's on Android, she downloads the APK and then decompiles it and finds out what new releases, what new features there are. Because as you know, that a lot of apps, you might do this as well in your own time, in your own work. A lot of apps release features for A/B testing or beta testing or feature flag, just like that, before it's actually released. And a lot of companies do that. All of these companies, all of these products do this. And she finds, but they're still in the app code, so she finds out about them. So for example, Facebook working on hiding like counts. Instagram working on comment sharing. And this is an example where Twitter was testing subscribe to conversation, so you can get notified on a conversation without liking or replying. And it was actually launched 147 days before she found it. And the only reason she found it is because the code existed. And this just goes to show that if a person can infer the features of an app based on the code in the app source code, which is shipped into the public store, then any secrets, like anything, no matter how well you hide them, are not secret within your app source code. And you might wonder how she does it. Well, she's quite private about this, rightly so, because she doesn't want this to be used maliciously. But on a high level, she basically gets the APK, she decompiles it, and then just does some clever sniffing through source code to figure out what's changed. Which is pretty cool. I'm like in awe of this person, also terrified. I hope I never make anything that's cool enough to be on her radar. Right, let's talk about async storage. If you're not a React Native developer, you might not know this, but async storage is the kind of React Native equivalent to local storage. It's the place we store the Redux state, the Apollo cache, like that kind of stuff. And this definition is actually from the React Native documentation, I think. It is a simple, unencrypted, asynchronous, persistent key value storage system that is global to the app. And it should be used instead of local storage, which is correct. But the key value here is unencrypted. So, what should you use async storage for? Persisted app state? Absolutely. Anything in Redux? Go for it. Any Apollo cache or Oracle cache? Go for it. But not your tokens. This is kind of a side note. Async storage is sandboxed for each app. So for example, if I have my Facebook app and Facebook app stores something in async storage, then this adjacent app, like an Instagram app, wouldn't be able to read Facebook's async storage. So that's correct. However, this is an operating system restriction, which you might not know about, and it could be overcome. If you ever heard of rooting or jailbreaking, they're kind of equivalent ideas for iOS and Android. And what they mean is basically overcoming the operating system restrictions that are imposed by Apple and by Android. And basically in Android, having root access because it's Linux-based, and on iOS, giving your user privilege escalation, so that you can pretty much do anything. So anything that's kind of sandboxed is not 100% secure either. Right, recap. If the user shouldn't see it, do not send it via network request. Now, I don't mean that you shouldn't send tokens via network request. Obviously, you have to do that. But if it's any kind of information that you want to filter on the client side, just don't do that. Just filter on the server side, only give the user the data they're allowed to see. Do not ship it in the app code. So in React Native, I think it should come. I think this comes from a lot of web developers going to React Native, because on the web you kind of have your you have your backend, and you kind of have this CI step where you can have environment variables and like embed them into your code, and you know it's all secure. But even if you have them in environment variables, ultimately they end up in the app code. So like never do that. If you need any kind of tokens, they should come from an API request for that user. And do not save it in async storage. So you might be thinking, all right, nothing's secure, everything's terrible. Where can I store stuff? Well, there are native solutions for this. In Android, there's an Android secure shared preferences, and in iOS, there's iOS keychain. You should still encrypt this before storage if you want to be really safe, because jailbroken devices can still access this text, this in plain text. If you're using React Native, there are a couple of libraries. These are just two examples, and I'm not necessarily recommending one or the other, but these are just two examples of libraries that have unified this for React Native, so you could store your sensitive info. So you could, even if you're using Redux, there is a library that has your Redux state, and you can have one reducer that's stored in sensitive storage. So you have all of your like app stuff in most of the reducers, and you have one secure reducer that gets stored in a different place, which is probably the easiest way to handle it. Right, security tips. This is what you're all here for, right? Do calculate permissions on server side. So like we said, if the user shouldn't see it, do not send it, because if they're a bounty hunter, they will be hunting for that info. Only send users data that they're allowed to see, so this comes from number 1. do use secure storage, for example, React Native Sensitive Info or React Native Keychain for tokens and other sensitive info. Cool. Right, that's the security bit over. Let's talk about authentication. This will be fun. All right, OAuth 2 and OpenID. This is one of the most confusing concepts, I think, in authentication. It's almost annoying, because everyone knows about OAuth 2 and everyone knows about OpenID, and no one can really explain what they are, because they're similar but not quite. Well, I mean, that's a good way to put it. I've got this handy chart here that I nicked from Slack because I thought it was very pretty. But on a really high level, what OAuth 2 is, it's an authorization protocol. So you can think of it kind of like REST or GraphQL. It's instructions, not an implementation. So it's instructions on how to do authentication. So given that I am a client, my mobile app is a client, and I want the user to authenticate, but I don't want to handle all this hashing, hashing email, hashing passwords and all that kind of stuff. So what I can do is I can give this to a third party. So I'm going to ask the user to authenticate, give it direct them to a web view. I'm sure we've all seen this. They log in, which gives me an authorization grant. Then I give this to a service API. That gives me an access token. And then I swap my access token I can use my access token, which is a JWT, to access any protected resource. So I'm sure you got that. That was very easy. It wasn't easy. OpenID, right, what's the difference between them? So if OAuth 2 is a protocol, OpenID is the open standard for that protocol. So it means that things like Google or Identity Server or Ookla or Amazon, I think, they that are trusted service providers, you can authenticate your users through them, and you can just mitigate that authentication. And OpenID Connect is built on top of the OAuth 2 protocol, which is why they look incredibly similar, to a point that I could almost say that they are the same. Cool. So this is an example of an OAuth flow on React Native. So I've clicked login. This is in your identity server. So you can see this goes into a web view. The user puts in their username, puts in their password. You can choose to remember your login or not. And then here you can choose what resources in your profile the app gets access to. So you might have noticed that there was an email and a name, I think. And if you uncheck those, then as a user, with that token, you wouldn't be able to access that resources. So that's the main concept of OAuth. Cool. And most of us probably have used this. Maybe some of you have even implemented it on the web. But on native, it's a little bit different. There is a couple of unique security considerations that only come into play with native. All right, let's have a look at the actual requests for OAuth. So the way it works, firstly, you basically have two calls you have to do. There's an authorized call and a token exchange call. First, we ask the user to authenticate. So this basically is on the web view, so this triggers the web view. You're sending your client ID, your redirect URI, which is where to redirect the user back to after they've logged in, and then the scope, which is what parts of the user's profile you want access to. So for here you could, for example, have email, name, address. If it's Fitbit does OAuth, you'd have sleep stats, things like that. After successful login, the provided redirect URI is called together with the verification code. And then on the client side, i.e. in the app, in our case, the verification code is exchanged for an auth token. And the auth token is a JWT, and then you would use that JWT in the headers of your requests, and you got access to your API. Cool. Now, let's look at the first problem. As we've spent a good chunk of time explaining, nothing is secret in a native app. So providing a client secret to a request as a method of security is completely redundant. A lot of APIs, OAuth API is still demanded, it's still mandatory, so sometimes you have to add it, but just so you know that this is no additional security. So if your API IDP does demand it, you'll have to send it, but just know yourself that this is not a, like, it's called a secret, but it's not. It's very public. Jane knows all about it. Right, and this is the other and potentially larger security consideration. It comes in step 2. After a successful login, the provided redirect URI is called together with a verification code. Now, on the web, redirect URIs are guaranteed to be unique. You have facebook.com/OAuth, and you know where that goes because it's registered to that particular IP. However, in the world of mobile, it's not quite so simple. Now, if you're an Android user, you've definitely seen this. If you're an iPhone user, hopefully you've kind of come across this. But basically, web addresses are unique, but app schemes are not. So this kind of view you'll get on Android if you try to open a link that can be opened by multiple applications. So in this case, it's probably a web link, and then you have it's probably a YouTube link actually, and you have 4 apps that can open this. So what Android does, it gives you a pop-up and goes like, all right, all of these can open it, which one do you want? And you can choose, and then you can do it just once or always. However, on iOS, you can't even choose. It actually just takes either the first or the last app that was installed, which you might already see that that's a security problem. Basically, as an app, I can listen to any redirect, any scheme, which is quite terrifying. So, and in Android, this is taken advantage of. So this is a feature of Android, but is actually a huge security flaw for OAuth, because as a result, if you are a malicious application, so for say I've built an app, it's called my app, and my redirect endpoint is //.myapp-OAuth redirect. A malicious application could go to my app code, go like, I see what your redirect endpoint is, and then they could install themselves on your user's phone, user's device, and listen to the same redirect scheme, which means that once the OAuth redirect comes back and tries to deep link into the app, instead of going into your app, it goes into the attacker's app, which means that they have full access to your API. And you don't want that. Thankfully, we have PKCE, or PXE, which is an extension to the OAuth 2 spec, which is specifically designed to make OAuth for public clients, i.e. on mobile devices, more secure. And it's designed to prevent this kind of man-in-the-middle attack. Right. Does anyone know about SHA-265? Well, just in case you don't, I'm going to do a quick run-through of what it is. So it is a cryptographic hash algorithm. And basically the way it works is, it's really cool. It translates it gives any piece of text or a file a unique signature hash that is exactly the same size, regardless of how big the input string is. And it cannot be decrypted back. So it's a one-way hash algorithm. So given a piece of text, you put the text in, you get this SHA out. You can't go the other way, but with the same piece of text, you will always get the same SHA, and it's pretty much guaranteed to be unique. Right, and this is used in security a lot, and this is also what's used in PXE. Right. Basically, there's 2 steps to this. First thing that we'll do is we're going to generate a large random string. So this is on the client side. As a client in our mobile app, before we do our authentication, we generate a huge random string, 100 characters, quite big. And then for the second step, we're going to compute its hash, which we call code challenge. So we run this 100-character length string through our hash generation algorithm, and we get that hash for that particular string. So now we have a code verifier, which is the big string, and we have a code challenge, which is the SHA of that string. And now let's look at how this fits into this request. So in the authorized request, we will send with the client's ID and the redirect URI in a scope, we'll send 2 additional parameters. One being the code challenge. So code challenge is the SHA for our randomly generated string. And also we'll send a code challenge method, which is usually SHA-256. They want to leave it open to extension. Right, so now we know that our IDP, our identity provider, has the SHA for that request. Right, so then step 2 works the same way. The user logs in, hopefully successfully, gives you a grant, and then we hook back into our app and with our authorization code. And now this is the point where we do the call to actually exchange our code to the token. But then what we do is with our token code, token exchange request, we also send the code verifier. So remember, code verifier was the actual, was the big string. Yeah. So first we send the hash, and now we send the big string. So on the client side, the IDP is stateful, so it remembers the code challenge that we sent before, and then using this code verifier, if you know this function, it can run SHA-256 with the code verifier, and then can check if it results in the code challenge that was sent in the original request. And that way you can guarantee that the application that sent the original authorized request is also sending the token request. And therefore, if this works, you get your token. If it doesn't, you're a malicious application and you can't get in. That's pretty much it. It's actually not that difficult when it's explained, but OAuth just seems like it's a crazy black box a lot of the time. But this is very important. It's not just React Native that needs this. Any mobile application is vulnerable to this kind of attack. Cool. So there are applications that do this for you, like they usually are in the world of JavaScript. And well, we're lazy. We don't want to do stuff. There are actually so App Auth for Android and App Auth for iOS. These are actually open source libraries that are built by OpenID. So OpenID is the whole organization to provide, encourage and provide this open authentication on the web. And there is also React Native App Auth, which is a library that I maintain, which is basically a bridge for App Auth Android and App Auth iOS to have a unified API within React Native. So basically, if you remember the GIF that we had early on, that is an example of a React Native app logging in using React Native App Auth. So if you don't want to handle all these requests on your own, and you trust me for some reason, you can use that library. And thank you so much for listening. I hope you learned something.